We are now on Chapter 3, Lesson 1. And the cool thing about Chapter 3 is that we're almost reviewing Chapter 1. The only difference is we're going to be using decimals now. So we're going to start by using base 10 blocks for our decimals. And you can see that we have our flat, our long, and our cube. But these are going to be worth different place values. So I'm going to start with the tens, the ones, a decimal, and 3 lines after it. So here is the tens, here is the ones. After the decimal is the tenths, then the hundredths, and last the thousandths. Now please note that all of these have a THS, which means after the decimal, this is now tenths, hundredths, thousandths. These values are different than tens, hundreds, and thousands. And in addition, after the decimal, know that there's no once, okay? There's no such thing. This flat is now going to be represented whenever we do the ones. So whenever we have the ones, we're going to be using a flat. So if you think of the flats and then the ones value, I think of it as a $1 bill, okay? And when we hit the tenths, what coin do we need if we were to have 10 of these coins to make $1? We would have a dime. 10 dimes equals $1. And same as 10 longs make a flat. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So tenths is 10 longs make 1 flat, or in other words, 10 dimes makes $1. Now when we move to the hundredths, I think of it as one of the small cubes because it takes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and from here I'm just going to count by tens, 20, 30, 40, 50, 60, 70, 80, 90, 100 of the small cubes to create a 1. So here, the hundredths will be represented by the small cubes. Just like in the last chapter, make sure that the flats and the small cubes have different sizes. The flat should be larger, the long should be long, and then the small cube should be tiny. Then we have something called the thousandths here. Now I forgot to mention, the hundredths is kind of like a penny. It takes 100 pennies to become $1. So here's our ones, our dollar bill, our tenths, our dimes, and our hundredths, our pennies. When we're going to money, if you notice, whenever we talk about money, it's like $35.67, $9.82. We always have a decimal followed by 2 numbers. When it comes to money, we don't actually hit the thousandths. So that's why when you see these weird pictures, the thousandths would be like this little small cube. And then like you see in maps and stuff, like when you're looking at Alaska, when you're looking at Hawaii, there's something called an inlet. And so this right here is like a magnifying glass. It's kind of magnifying this little small cube. And what we're doing with this little small cube is we're imagining we're taking the hundredths, which is like the penny, and we're making it even smaller than it already is. Because the thousandths is smaller than the hundredths. So what we're doing with it is we're dissecting it. So here's a small cube magnified. That's why like there's this circle and it looks magnified. And we're going to split it into 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, when you're drawing this out, you only need to create 9 lines, and that will give you 10 spaces. So as you saw, I drew my square, and then I went 1, 2, 3, 4, 5, 6, 7, 8, 9, and I only drew 9 lines. And when you count them, you actually have 10 spaces already. So don't get confused by drawing 10 lines, because then you end up with 11 spaces. So quick review. This flat will represent our ones. The tenths will be represented by the longs. The hundredths will be represented by the small cube. And the thousandths will be this inlet that kind of dissects this small cube into 10 small pieces. So what you're going to do is you're going to draw a small cube, draw this magnifying glass, and then cut it into 10. To cut into 10, you make a square, and then you count 9 lines. That being said, let's look at problem number 1. Number 1, they give you a picture. And what they're asking for is they want you to represent this picture into standard form or as a number. And so we're going to be, for number 1, don't look at the answer key. To show our work, we're going to do tens, ones, decimal, tenths, hundredths, thousandths. So tens, ones, tenths, hundredths, thousandths. Please write it a little neater than mine. I'm just doing this for demonstration methods. The tens, I know I didn't mention that yet, but those are the ones, let's see if I have one of them. They're going to be our large cube. So to draw the cube, if you remember, it's a square within another square. And then you just connect the bottom left to the bottom left, bottom right with the bottom right, top left to the top left, top right with the top right. The tens are represented by the large cube. And only with the large cube will you make it 3D. If you're talking about the small cubes, like you do with the hundredths and the thousandths, do not make them 3D. And you're going to ask yourself, in this model representation, are there any large cubes? No. So you could put the number 0 there. So we're looking for any large cubes. There was no large cubes. Now the ones is represented by the flats, your $1 bill. Okay. Are there any 1 holes? If you look here, you have a flat, but are all of them shaded in? No. So at this point, in terms of our flats, we have none. Now we're looking at our tenths. The tenths are represented by the dimes, or in other words, the longs, because it takes 10 of these to create a flat. And so we're looking for any longs. Do we have any longs? We do. You can see that this whole columns go up and down. This whole column is filled out, so that's 1. Then if you look again, there's a second one all filled out, that's 2. This third one is not all filled out. You could see here that these ones are empty, so we can't count to 3 here. We have 2 complete longs. We have 1 complete long, 2 complete long, and we can't say 3 because it's not all filled out. So under the tenths, we have 2 longs. Now we're looking for the next one. The next one are our pennies, or our small cubes, because it takes 100 of these to create one of these. That's why they're called hundredths. These are called tenths because it takes 10 of these to create a flat, and these are called the hundredths because it takes 100 of these. Do we have any small cubes? Now we already counted these 2 rows, so we're not going to count them again. We're going to count our extra ones. And you can see here we have 1 shaded in, 2 shaded in, 3 completely shaded in. This 4th one is not shaded in, so we cannot count it. So right here we have 1, 2, 3 completely shaded in small cubes that we didn't count yet. So we have 3 small cubes. And now we're in the thousandths. Keep in mind the thousandths is we don't have a whole cube. So you could see here that these inlet, these arrows, point to this one right here, and it's not colored in. What's happening with this small cube is we're dissecting them, and we're cutting them into 10 slices. 1, 2, 3, 4, 5, 6, 7, 8, 9 will create 10 slices. And we're going to count how many. And this one's a little tricky, so I'm going to zoom in a little. And you're going to see 1, 2, 3, 4, 5, 6, 7. Actually, I think it's 6. 1, 2, 3, 4, 5, 6. Whoops. Actually, it's 6. And I can tell because there's 4 empty. So here we have 6 thousandths colored in. And I kind of messed up counting it here, so let me count again. 1, 2, 3, 4, 5, 6. So we have 6 of the 10 colored in, so our thousandths is 6. So we had no cubes, large cubes, no complete flats. We had 2 longs, tenths, 3 small cubes, hundredths, and 6 tenths of a hundredth, so 6 thousandths. And that's our answer right here. 0 and 236 thousandths. Now, we're going to be practicing saying this number in the next lesson because 3-2 is all about word form, expanded form, and other things like that. So I'm not going to go over that too much, but right now you could say 0.236 at this 3.1 lesson. But at 3.2, I will be expecting you to use proper terms, such as when you see a decimal, we'll say and. And we will never say 0.236, we'll say 236 thousandths. That being said, I think you can kind of get the gist of how to do number 2. Just make sure that you're showing your work by going, labeling this as tens, ones, tenths, hundreds, thousandths, and underneath drawing a picture of what you're looking for at each of those stations. All right, so I'm going to take a quick break for a second and resume in a second. Okay, before we start number 3, I kind of want to review some of the vocabulary that we used back in chapter 1. When you see blank times as much as, that means bigger than. That whatever number is to the left is bigger than the number to the right. And the numbers that will go here, since it's bigger than, are whole numbers. So it might be 10 times as much as, it might be 100 times as much as, it might be 1,000 times as much as, and so forth. 10,000, 100,000, and so forth. Likewise, if you see 1/10 of, or 1 blank of, that means less than. And since it's less than, it's part of something, it's a fraction of something, so this fraction will either be 1/10 of, 1/100th of, 1/1000th of, and so forth. So first off, keep in mind that times as much as is bigger than, and a fraction of is less than. And the fraction is usually going to be 1/10th, 1/100th, 1/1000th, and so forth. That being said, another thing I want to warn you against, because I've seen a lot of students make this mistake, is that knowing the tenths is larger than, bigger than the hundredths. And I know you're thinking to yourself, but 10 is less than 100. Yes, but that is for whole numbers. When we're talking about decimals, the tenths are the dimes, and the hundredths are the pennies. If you have 8 tenths, if you have 8 dimes, that is going to be worth more than 8 hundredths or 8 pennies. This is worth 80 cents, and this is worth 8 pennies. And let me kind of prove that to the side here. So if you look at this little corner, I'm going to just draw a little corner here to kind of show you. 8 tenths, because that's the tenths, versus 8 hundredths, because that's the hundredths. If you were to add an extra 0 here, 80 cents is more than 8 pennies. 8 tenths, 8 dimes is worth more than 8 pennies, 8 cents. 80 versus 8. So that's that. It's important to keep in mind that tenths is bigger than the hundredths, and tenths is bigger than the thousandths. The hundredths is bigger than the thousandths. If you don't know that concept, then you're really going to struggle through. So make sure to ask when things get a little confusing there, because I can remind you. That being said, let's look at number 3. 4/10 is 10 times as much as. So the first thing I'm going to do to show my work is that we're looking at the tenths value here. 4/10. So we're going to be saying tenths, and then you're going to say is 10 times as much as means bigger than. So tenths, because that's the place value, is bigger than. And over here, you're going to tell me the two things it's bigger than, or more. The tenths, these longs, are bigger than the hundredths, and they're bigger than the thousandths. So it's both bigger than the hundredths, and it's also bigger than the thousandths. Now, if it's 10 times as much as, then you're only going to go from one place value to the next. So tenths is bigger than both the hundredths and the thousandths. But since you only have 10 times as much as, it's the one directly to the right. So it's the hundredths. If it said 100 times as much as, then you're going to go, because they'll have 2 zeros, you'll go 1, 2. But since it has 1 0, you're going to do the hundredths. So your answer is 4/10 is bigger than 4 hundredths. And all you have to do is write 4 hundredths down. So how do you write 4 hundredths? It's a 0 followed by a decimal, nothing in the tenths, and something in the hundredths. 4 hundredths. 4/10 is bigger than, by 10 times, the 4 hundredths. Let's try that again. 3 thousandths. So here, what we're going to do is underline the place value. And we're going to determine what place value this is. And don't take any shortcuts. Go the long way. Here's where the decimal is, so the number to the left of it is the ones. Once you hit the decimal, it's the tenths, hundredths, thousandths. So let's practice saying that again, no shortcuts. Ones, decimal, tenths, hundredths, thousandths. So this number right here is said 3 thousandths. So 0.003, I don't want to hear you saying. I want you to say it as 0 and 3 thousandths. Now when you see the 1/10 of, you look at our cheat sheet here, 1/10 of means less than. So 3 thousandths is less than. Now let's look at our cheat sheet here. The 3 thousandths is less than, which means smaller than, and smaller than all of these actually. It's smaller than the hundredths, it's smaller than the tenths, it's smaller than the ones, and it's smaller than the tenths. So we're going to write that. It's smaller than the hundredths. And you could see, I'm going to the one directly to the side of it. The thousandths is smaller than the hundredths, which is our pennies, or our small cubes. It's smaller than the tenths, which are also our dimes. And it's also smaller than our ones, which are our dollar bills or our flats. Now, which of the answers is it? 3 thousandths is less than all of these, but how do we know which one it is? To look at that, we'll look at our fraction. Because it's 1 0, it's only one place value less than. So if you go from the thousandths, because this is a 10, there's only 1 0, you're going to go to the hundredths, and this one's your answer. Although it is smaller than the tenths, and it is smaller than the ones, this denominator has 1 0, so you're only shifting one place to the left. So our answer is going to be 3 thousandths is less than 3 hundredths. And all you have to do for the answer now is write 3 hundredths as in standard form. So to write 3 hundredths in the standard form, you're going to say ones, decimal, tenths, hundredths. Your 3 should go in the hundredths place. Nothing in the ones, nothing in the tenths. And your answer is 0.03, or 0 and 3 hundredths. Okay, now we're going to be working on the word problems. The diameter of a dime is 705 thousandths of an inch. Complete the table by recording the diameter of a dime. Before you try solving the problem, if they say complete the table, you might want to take some time to actually look at the table. So before reading what to do, trying to solve an answer, look at what the table is saying. So we have a table to the right about US coins, and on the left side they're labeling different coins. They have the penny, nickel, dime, quarter, and half dollar. And then on the right side they're saying diameter in inches. So you probably know what an inch is because you've seen a ruler. But diameter, if you're not familiar with that term, don't worry, we'll be talking more about it in, I think it's chapter 9. But for right now, diameter is going, it's a straight line going through the center, going from left to right. So the diameter is from like one edge to the next. And since it's a circle and it's equal, you go this way, you go that way. But so long as it passes the center point, and it goes from one end to the next. So what they did was they took a ruler and they measured the diameter of different coins, the penny, nickel, dime, quarter, and half dollar. And you can see in the chart that the dime section is blank. So if they're asking for a number 13, the diameter of a dime is 705 thousandths of an inch. Here, you don't need to take a ruler to figure it out. They told you the number already, but they want you to write that number inside of the table using standard form. So they gave you word form right now and said 705 thousandths of an inch, and they're expecting you to write that number here. So what does that look like? Let's look at our cheat sheet here, and we know that we have the tens, ones, decimal, tenths, hundredths, thousandths. So when they're saying the diameter is 705, that looks like this. 705 is 705. 705 thousandths of an inch. That means the last number, the 5, should end in the thousandths, which is this one right here. 705. And we have no tens and we have no ones. And so here you could write what some people will say 0.705 or 0 and 705 thousandths. But I want you to make sure that you're labeling everything. So under the 7, write your tenths. Under your 0, write the hundredths. And under the 5, write the thousandths. And you can see here, 705 thousandths. And literally that's all you do. For number 14, it's going to be something, I wouldn't want to say simple because I don't want to say easy and hard when we're talking about math, but it is something where all you have to do is reference the chart and solve it. There's no picture box to this one. There's no adding, subtracting, multiplying, dividing. It's more understanding, do you know what the place value is? Not all lessons within this chapter are going to be that simple. Sometimes you will have to add, subtract, round, and then talk about the place value. But for this particular lesson, because I reviewed all the questions already, they all just want to make sure that you understand place value. So you won't be using the part, whole picture boxes for this one. So rest your mind a little. Number 14, what is the value of the 5 in the diameter of a $50? So here they want you to look at the $50, and this is where you have to use your skills in terms of reading a graph. You're looking for the coins. The penny you're not concerned with, because in the directions it said the half dollar. So you're going to skim down the coins of penny, nickel, dime, quarter, and half dollar and stop there. Then they said, what is the value of the 5 in the diameter? So you're going to look at the diameter column where the half dollar is. You're concerned with this number right here, where it's a 1.205, which we don't want to talk about it like that. We want to say 1 and 205 thousandths. I'll show you how I get that number in lesson 3-2, but for now, just trust me, it's 1 and 205 thousandths. And they want to know what is the value of the 5. So what I'm going to do is I'm going to underline the 5, and I'm just going to do what I did with chapter 1. No shortcuts, go from left to right, tell me all the place values. So on the left side is the ones, then the decimal, tenths, hundredths, thousandths. If they want to know the value of this number right here, let's try saying it again. Start from left to right. Ones, decimal, tenths, hundredths, thousandths. The value of the 5 in the diameter of a half dollar is 5 thousandths. Okay, I hope that helped. Do work on number 15 on your own, and let me know if you have any questions. Have a good day.